Hello, once again. Today we are going to talk about some important points regarding velocity time graph. Okay, and on a velocity time graph, we know that we will have velocity v measured meters per second on the y-axis, and we will have time measured in seconds and represented on the x-axis. This point represents the origin O. Okay. What is important to note about the motion of an object is the first point is the body performing acceleration. The second point is the body performing deceleration, which is sometimes called retardation. And the third point is the body maintaining a constant velocity or speed. Okay, that is also called steady velocity or steady speed. What we need to know about acceleration is that when a body is performing or a body is in acceleration, its velocity progressively increases. Okay, so for acceleration, what happens? Velocity increases. All right. For deceleration, the body's velocity decreases progressively. Okay. When a body neither increases nor decreases its velocity, in other words, the body is maintaining or moving at a certain velocity or speed, we term the body to be having a constant velocity or speed. Okay, so but then how do we represent these points on the velocity time graph? The other important thing to note is the body moving from rest, or the body is moving initially at a specific initial velocity. This point is important to note. If a body is moving from rest, its initial velocity u is equals to 0 meters per second. Okay? So, if a body that is moving comes to rest, that is the body ceases its motion, it means the final velocity v is equals to 0 meters per second. All right. So let's just move on to the velocity time graph and try to give the detailed explanation. For acceleration, because the body progressively increases its velocity, let's assume that here the body starts moving from rest. So it means it has to start from the origin. How do we represent an acceleration? It is a straight positive slope. Okay, this is called acceleration. So here I am assuming that the body starts moving from rest and then progressively increases its velocity. So a body that is increasing its velocity is in acceleration. All right, and at this point here, the body reaches a certain velocity, okay, which can be calculated. Let's call it v. Okay, we know that to find v is equals to u plus at. That is, the final velocity is equal to the initial velocity plus the acceleration multiplied by the time. Okay, so this point from here way up to this point, it is called acceleration. So if you look at it with change in time, the body's velocity is increasing. That is called acceleration. All right. So let me just call the time interval from this point here where the body starts accelerating to this point where its acceleration ended. Let's call the time interval as t1. All right. Okay. So let's say that after the body accelerated, it maintains a constant velocity. So how do you represent that on a velocity time graph? When a body is maintaining a constant velocity, as the name implies, the velocity doesn't change. So we can only represent that by maintaining a straight horizontal line. Okay, so which means from this point here way down to this point, the body was maintaining a constant velocity. Okay, so we can say, let's say, the time that has elapsed, or the time taken while the body was maintaining a constant velocity, let's just call it t2. Right, this point, should we label it? Yes, let's say is constant velocity. All right, the constant velocity, the point from here way down to this point, the body was maintaining a constant velocity. The velocity didn't change. Okay, so moving on to deceleration. Deceleration is when the body is decreasing its velocity. Okay, so how do you represent that? Let's assume that the body is decreasing its velocity and comes finally to rest. Okay, that is, from this point way down to this point. Okay, as you can see, it touches the horizontal line, so which means the body comes to rest. This is called deceleration. Okay, it is called deceleration. All right, so let's just go over it quickly. If a body starts moving from rest, it accelerates uniformly to reach a constant velocity. This line from here to this point is the acceleration. After the body attains a steady velocity, if it maintains that steady velocity, we represent it with a horizontal line. That is, from this point way down to this point, it is called the constant velocity. So if from this point the body reduces its velocity to come to rest, that is going to be from this point way down to this point. That is called deceleration. Okay, and the time elapsed for the deceleration, let's call it T3. Okay, so other important things to mention is that a body may start accelerating from a certain velocity that is greater than 0. A body's deceleration does not always have to come to rest. So that is, if a body is decelerating, it does not mean that it always have to come to rest. So understanding the velocity time graph actually is important. All right, let's say I draw something like this. Okay, then I have a line like this, I have a line like this, a line like this, and then let's see, I have a line like this, then a line like this. Okay, this is time in seconds. I'll have velocity in meters per second. What can we say? Let's say point A, point B, point C, point D, point E, point F about this velocity time graph here. From point A way down to point B, the body is in acceleration. See, because the speed is increasing progressively. If you should follow it on the y-axis, that is the axis representing velocity. So this point is called acceleration. But here the body accelerated from a certain velocity, not from rest. Okay, if it's accelerated from rest, then it's going to start from the origin, like the first graph that I have shown. But that is not the case here. Okay, that is not the case here. So if I'm considering this graph again, the body accelerated from point A to point B. Okay, to point B. This is called acceleration. All right, and obviously the time that has elapsed from here to here, we can call it time 1. Okay, so from point B to point C is a horizontal line. So what does that mean? It means that the body was maintaining a constant velocity. Okay, and that was a time that elapsed. So let's just call that T2. Okay, so from point B to point C, time has elapsed from this point way to this point. And during this interval, the body was maintaining a constant velocity. So from point C way down to point D, here what happened, if you look at it from C to D, the body's velocity was decreasing. And what is that? That is called deceleration. Okay, the other word for deceleration is what? Retardation. Deceleration. But like I said, not all deceleration will bring the body to rest. So a typical example of it is shown here. If you look at it, from C to D, obviously the velocity has reduced, but the body has not come to rest because it has not progressed to touch the x-axis. Okay, that's a deceleration. All right. So from point D to E, before moving to that, so the time that has elapsed during deceleration, we can call it T3 here. Okay, now if you look at point D to E, what is the thing that is obvious is that the body maintains a velocity. Okay, it maintains a constant velocity from D to E. The velocity didn't change, so we also have a constant velocity here. Constant velocity. All right, so what about point E to F? Point E to F, what happens actually, we can see that the body's velocity was reducing until it touches the horizontal line. So this is also a deceleration, but deceleration, the difference is that it is a deceleration that brings the body to rest. Okay, so acceleration will be a positive value, remember that, but deceleration will be, acceleration will be a positive value, but deceleration will be a negative value. Always remember that. Okay, so that is all I have for you regarding the basics that you need to know when dealing with a velocity time graph. You can continue to watch other videos where I solve problems regarding velocity time graph. Thank you.